Good afternoon, everyone. So this afternoon, I was tasked to report about check digits. Before we start, here are the following objectives. First, define check digits. Second, perform and how to calculate check digits. When we say check digit, it is the last digit of an identification number that can be found in airline ticket number and any postal money order and any bank routing number, in universal product codes or any products that we're going to purchase, and in international standard book numbers. It could also be found in zip codes or any credit card. Why do check digits exist? It exists to make sure that there is no human error when entering or writing any UPC, an airline ticket number, or any ISBN number. So there are common errors. It could be single errors, which is typing the wrong number, or it is just a single digit, which is incorrect. Then transposition, it is typing 23 instead of 32, or two digits are being switched. Then phonetic error, it is typing 14 instead of 40. Let's start with airline ticket identification number algorithm. So if there are 12 digits in an airline ticket number plus a 13 digit, the number represented by the first 12 digits alone divided by 10 should yield a remainder equal to the check digit. So we have to use this algorithm: a sub 1 plus 3 times a sub 2 plus a sub 3 plus 3 times a sub 4 plus a sub 5 plus 3 times a sub 6 plus a times 7 plus 3 times a sub 8 plus a sub 9 plus 3 multiplied to a sub 10 plus a sub 11 plus 3 times a sub 12 plus a sub 13 is congruent to 0 modulo 10. Or in finding check digit, you can use a sub 13 is congruent to a sub 1 plus 3 times a sub 2 plus a sub 3 plus 3 a sub 4 plus a 5 plus 3 times a sub 6 plus a 7 plus 3 times a 3 times a sub 8 plus a sub 9 plus 3 times a sub 10 plus a sub 11 plus 3 a sub 12 modulo 10. Let's start with an example for airline ticket identification number. If the 12 digits of Philippine airline ticket number are 079-218-174317, find the 13th check digit. So first, we have to label all the digits from A sub 1 up to A sub 12. So from 0 as our A sub 1 up to 7 as our A sub 12. After labeling, we have to use the congruence given in determining airline ticket identification number check digit. So A sub 13 is congruent to A sub 1 plus 3 A sub 2 plus A sub 3 up to plus A sub 11 plus 3 A sub 12 modulo 10, in which all odd numbers is multiplied by 1 and all even numbers is multiplied by 3. Since we have the values of A sub 1 up to A sub 12, we have to substitute them. So we have here a sub 13 is congruent to 0 plus 3 times 7 plus 9 plus 3 times 2 plus 1 plus 3 times 8 plus 1 plus 3 times 7 plus 4 plus 3 times 3 plus 1 plus 3 times 7 modulo 10. Then perform the indicated operations. So we have here a sub 13 is congruent to 0 plus 21 plus 9 plus 6 plus 1 plus 24 plus 1 plus 21 plus 4 plus 9 plus 1 plus 21 modulo 10. Then add the following values. So we have here A13 is congruent to 119 modulo 10. So 119 modulo 10 is 9 modulo 10. So if we divide 9, if we divide 119 by 10, we have a remainder of 9. So our A13 is 9. Therefore, the check digit of the Philippine airline ticket number is 9. So the remainder of the given value is our check digit. So here is an actual Philippine airline ticket number from Philippine Airlines. So the same check digit, which is 9. Let's move on to bank identification number. So the US banking system uses a variation of the UPC scheme. So a bank identification number is 9 digits long. The first 4 digits identify the bank's Federal Reserve District. The next 4 digits identify the specific bank. The last digit is a check digit. The check digit A sub 9 is the last digit of the sum. So we have to use A sub 9 is congruent to 7A sub 1 plus 3 multiplied to A sub 2 plus 9A sub 3 plus 7A sub 4 plus 3 times A sub 5 plus 9 times A sub 6 plus 7 multiplied to A sub 7 plus 3 multiplied to A sub 8 modulo 10. Here an example for bank routing number. So the First Chicago Bank has the routing number 170 4 zeros, 1 and 3 on the bottom of its checks. Confirm that this is a valid bank identification number. So first, we have to label all the digits from A sub 1 up to A sub 9. So from 0 up to 3. So after labeling all the digits, we have to use the congruence. A sub 9 is congruent to 7 multiplied to A sub 1 plus 3 multiplied to A sub 2 plus 9 multiplied to A sub 3 plus 7 times A sub 4 plus 3 times A sub 5 plus 9 times A sub 6 plus 7 times A sub 7 plus 3 times A sub 8 modulo 10. Since we have the values from A sub 1 up to A sub 9, we have to substitute. So we have here 7 times 0 plus 3 times 7 plus 9 times 1 plus 7 times 0 plus 3 times 0 plus 9 times 0 plus 7 times 0 plus 3 times 1 modulo 10. Then perform the indicated operation. So we have here 0 plus 21 plus 9 plus 4 zeros plus 3 modulo 10. Then add 21 plus 9 plus 3 will become 33, then modulo 10. So 33 when divided by 10, we have a remainder of 3. So our A sub 9 is 3. Since the remainder of 33 when divided by 10 is 3. So this is a valid bank identification number. Since our check digit given is 3 and we arrive at the same number, which is 3. Let's move on to International Standard Book Numbers or ISBNs. I have here ISBN 10 and ISBN 13. So let's start with ISBN 10. The first digit 0 indicates the language or the country where it was published. Then the next few digits indicates the publisher, the specific book, or its serial number. Then the last digit indicates the check digit. Then on ISBN 13, the first digits 978 indicates its prefix, then it follows the same pattern as ISBN 10. So most books published since 2007 have a 10-digit ISBN code and a 13-digit ISBN code. The groupings of numbers may vary in length except for the check digit, which is always a single digit. Let's start with ISBN 10. So how we going to calculate check digits? So given the summation of I multiplied to x sub I, where I ranges from 1 to 10, is congruent to 0 modulo 11. Given the ISBN 10, x sub 1, x sub 2 up to x sub 10, where x sub 10 is the check digit, which basically means we take each digit of the ISBN and multiply by each number in order from 1 to 9, then sum of the digits of our product and simplify using modulus 11. So we have here ISBN from x sub 1 up to x sub 10, then its multiplier from 1 to 10. So we have the sum or the modulus. So x sub 1 multiplied to 1 will become 1 times x sub 2. Then the same thing you do. So x sub 2 multiplied to 2 plus 2 times x sub 2 up to x sub 9 multiplied to 9. So plus 9 times x sub 9 plus 10 multiplied to x sub 10 is congruent to modulo 11. Let's have here an example for ISBN 10. Show that there is an error in the ISBN 0061689077 of the Lost Girls. If this was a valid ISBN, we want to show 1 multiplied to x sub 1 plus 2 multiplied to x sub 2 plus 3 multiplied to x sub 3 up to plus 10 multiplied to x sub 10 is congruent to 0 modulo 11. In order for us to say that the given ISBN is valid, so it should have arrived at 0 modulo 11. So first, we have to label all the digits from x sub 1 up to x sub 10. So from 0 as our x sub 1 up to the last digit 7 as our x sub 10. Then, by using this congruence, we have to substitute the given values from x sub 1 up to x sub 10. So we have here 1 multiplied to 0 plus 2 times 0 plus 3 times 6 plus 4 times 1 plus 5 times 6 plus 6 times 8 plus 7 times 9 plus 8 times 0 plus 9 times 7 plus 10 times 7 is congruent to 0 modulo 11. Then perform the indicated operation. So we have here 0 plus 0 plus 18 plus 4 plus 30 plus 48 plus 63 plus 0 plus 63 plus 70 is equal to 296 modulo 11. So 296 modulo 11 is equal to 10 modulo 11. For if we divide 296 by 11, we will have a remainder of 10. Since we have 10 modulo 11 instead of 0 modulo 11, this means that the ISBN 10 given for this particular book is incorrect. Since the remainder is 10, so as we all know, the check digit is the remainder of the given values. So this ISBN of this particular book is incorrect. Since the given ISBN for the book The Lost Girls is not valid, so we have here an example, which is to assume that the first 9 digits of the ISBN 006168907-7 are correct. What should be the final digit actually be? So this time we have to determine the correct check digit. But first, we have to label all the digits from x sub 1 up to x sub 10. So from 0 up to 7. So after labeling, we have to use this congruence. X sub 10 is congruent to 1 multiplied to x sub 1 plus 2 multiplied to x sub 2 plus 3 multiplied to x sub 3 plus 4 multiplied to x sub 4 up to plus 9 multiplied to x sub 9 modulo 11. Since we have the values from x sub 1 up to x sub 9, so we have to substitute the following values. So we have here x sub 10 is congruent to 1 times 0 plus 2 times 0 plus 3 times 6 plus 4 times 1 plus 5 times 6 plus 6 times 8 plus 7 times 9 plus 8 times 0 plus 9 times 7 modulo 11. So after that, we have to perform the indicated operation. So we have here x sub 10 is congruent to 0 plus 18 plus 4 plus 30 plus 48 plus 63 plus 0 plus 63 modulo 11. Then add the following values from 0 up to 63. So we will have here 236 modulo 11. If we divide 236 by 11, we will have a remainder of 6. So x sub 10 is congruent to 6 modulo 11. Since the remainder is 6, it means that the last digit of the ISBN should be 6, which means the correct ISBN of the book The Lost Girls is 006168907-6. It is 6. So we have here the correct ISBN for the book The Lost Girls to make it valid. So the check digit is 6. Next, so let's move on to ISBN 13. Given an ISBN 13 code with the digits A sub I, which I ranges from the values 1, 2 up to 13. So each odd numbers is multiplied by 1. So odd numbers is multiplied by 1 and each even number is multiplied by 3. Then the digits of our product are summed and then calculated using modulo 10. So we have to use this congruence. So from A sub 1 plus 3 multiplied to A sub 2 plus A sub 3 plus 3 multiplied to A sub 4 plus A sub 5 plus 3 times A sub 6 plus A sub 7 plus 3 multiplied to A sub 8 plus A sub 9 plus 3 multiplied to A sub 10 plus a sub 11 plus 3 multiplied to a sub 12 plus a sub 13 is congruent to 0 modulo 10. So we have to use that congruence in order to calculate the check digit or to say that the given ISBN 13 is valid. Let's have here an example for ISBN 13. Using the algorithm for the ISBN 13, prove that the ISBN 978-013-4689-463 of A Friendly Introduction to the Number Theory by Joseph Silverman is the correct ISBN, including the correct check digit. So first, we want to show that A sub 1 plus 3A sub 2 plus A sub 3 up to plus 3a sub 12 plus a sub 13 is congruent to 0 modulo 10. So all the digits or odd digit or even number is multiplied by 1, and then even numbers are multiplied by 3 congruent to 0 modulo 10. So first, we have to label all the digits from a sub 1 to a sub 13. So from 9 as our a sub 1, then 3 as our a sub 13. After labeling all the digits, we have to use the congruence given for ISBN 13. Then substitute the given values from a sub 1 up to a sub 13. So we have here 9 plus 3 times 7 plus 8 times plus 3 times 0 plus 1 plus 3 times 3 plus 4 plus 3 times 6 plus 8 plus 3 times 9 plus 4 plus 3 times 6 plus 3 is congruent to 0 modulo 10. After that, perform the indicated operations. So we have here 9 plus 21 plus 8 plus 0 plus 1 plus 9 plus 4 plus 18 plus 8 plus 27 plus 4 plus 18 plus 3 is equal to 130. And then modulo 10. So 130 modulo 10 is equal to 0 modulo 10 because when we divide 130, the remainder is 0. So that means we have a valid ISBN 13 and 3 is the correct check digit since we arrive at 0 modulo 10. So the ISBN for this book, A Friendly Introduction to the Numbers Theory, is valid. So let's move on to Universal Product Codes or UPCs. So I have here a UPC which is a 12-digit number in which its first digit, which is 0, identifies the category of goods or the number system. Then the next 5 digits identifies the manufacturer. Then the next 5 digits identify the product or the item. Then the last digit is the check digit. So the UPC has 12-digit number and have an algorithm similar to the ISBN 13 that is used to determine the check digit. So the 12-digit UPC used in the US paved the way for the 13 EAN or European article number used in Europe, which became the worldwide standard. So I given a UPC with digits A sub I, where I ranges from 1 up to 12. So each add e numbers is multiplied by 3 and each even numbers is multiplied by 1. So the check digit is determined by the congruence. So the congruence used is from 3 multiplied to a sub 1 plus a sub 2 plus 3a sub 3 up to plus 3a sub 11 plus a sub 12. So see, the even numbers is multiplied by 1 and the odd numbers is multiplied by 3, congruent to 0 modulo 11. So I have here an example. Let's have an example for UPC. Using the algorithm for UPC, prove that the UPC 014285003076 of UFC tomato sauce Filipino style is the correct UPC, including the correct check digit. So first, we have to label all the digits from A sub 1 up to A sub 12, from 0 as our A sub 1 up to 6 as our A sub 12. Then use the given congruence for UPC, in which all odd numbers is multiplied by 3 and all even numbers is multiplied by 1. So this is only used for 12-digit UPC. Is congruent to 0 modulo 10. Since we all have the values for A sub 1 up to A sub 12, then plug in all those values. So we have here 3 times 0 plus 1 plus 3 times 4 plus 12 plus 3 times 8 plus 5 plus 3 times 0 plus 0 plus 3 times 3 plus 0 plus 3 times 7 plus 6 is congruent to 0 modulo 10. Perform the indicated operations. We have here 0 plus 1 plus 12 plus 2 plus 24 plus 5 plus 2 zeros plus 9 plus 0 plus 21 plus 6 is equal to 80, then modulo 10. 80 modulo 10 is 0 modulo 10. Since the remainder of 80 is 0 when divided by 10, that means we have a valid UPC and 6 is the correct check digit. Since we arrive at 0 modulo 10 or it is congruent to 0 modulo 10, the given UPC for this product is valid. Let's move on to an example for 13-digit European article number. Determine if the Czech antibacterial soap UPC 480374668429 is valid. First, let's have to label all the digits from A sub 1 up to A sub 13, from 4 as our A sub 1 and 1 as our A sub 13. Then use the congruence in determining 13 AEN or European article number in which all odd numbers are multiplied by 1 and all even numbers are multiplied by 3. Then I'll add all of those is congruent to 0 modulo 10. Since we all have the values for A sub 1 up to A sub 13, then plug in all those values. So we have here 4 plus 3 times 8 plus 0, plus 3 times 3 plus 7, plus 3 times 4 plus 6, plus 3 times 6 plus 8, plus 3 times 4 plus 2, plus 3 times 9 plus 1 is congruent to 0 modulo 10. Then add all those given values. We have arrived at 130, then modulo 10. 130 modulo 10 is 0 modulo 10. Since the remainder of 130 is 0 when divided by 10, that means we have a valid UPC and 1 is the correct check digit. Since we arrive at 0 modulo 10, the Czech antibacterial soap UPC is valid. So that is all about check digits. I have here an activity, items from 1 to 4. So kindly answer the given activity. So that's all about check digits. Thank you for listening. May God bless you and stay safe.